Okay, so option A is invalid, not correct, because there's two products, or yeah, two products instead of one, which violates condition, because there's only supposed to be one, not two. It also has the compound CO instead of a pure element. The same goes for option C. It's formed with a compound instead of a pure element. Option B is correct because they're pure elements. The coefficients, everything's balanced, everything's correct as well. So yeah, pure elements, these ones have compounds. So that's why B is correct. Let's see, so for problem number 2, I did the enthalpies formula, which is sigma n delta H F decimal product minus the reactants. Got everything, input it in. There, that. So I got 5314.08. That's pretty darn similar to 5315 kJ. So I'm probably just off somewhere by a decimal or a value. For C4H10, I couldn't find that value in the appendix. I double checked, so I googled it, and for that one it was negative 126.1. And then for pure elements, that's always 0, and then input the values, which is equal to that. And then I did the same for 2B, products minus reactants, plugged it in. 4NO plus 6H2O minus 4NH3 minus 5O2. So it's 4, plugged in the value for NO in the back of the appendix, 20.25 plus 6, negative 285.83 minus 4, negative 45.9 plus 5 times 0, because it's a pure element, which equals about 1170.38. There's a difference of 438 compared to the answer, which is 1166 kJ. It's pretty darn close. I think it's probably off somewhere, but I checked 4 or 5 times in the appendix. The values were right and everything. I did the products minus the reactants. NO, H2O, which is right here. Reactants are over here, NH3, 5O2 over there. So I'm probably just off a little bit with rounding or by the value. And then for this one, Hess's law. So I did it 2 ways. Essentially, I noticed that everything is multiplied by 3, like the reactants plus the product, they both are multiplied by 3, so 2 times 3 is 6. 1 times 3, 3, because there's 3 oxygen, 2, and then 2 CO2 times 3 equals 6. So essentially, I could just take the delta H times it by 3, which is why it would equal negative 1698, which is the correct answer. KJ, by the way. But I also double checked and put it into the formula as well, and I got the same answer, which is me double checking. But either way, just times it by 3, because that's exactly what we did to the equation. So for this one, just ignore this part right here. So how we went from this to this, according to the Hess law, was like A plus B equals C, C plus D equals E, that kind of stuff. So N2 are in both of the equations, so you can just cross that out or cancel out. And then I added 3 plus 4 H2 gas, which is why this is 7 H2 gas. And then this one is part of the reactant, so then it's 7 H2 gas plus 2 NO2 gas, which is from here, and then the product, the N right here after the arrow, there's like no similar or anything, so I just brought them down over to the right side, which is why it's 2H3 plus 4H2. And then for this one, I just took -69 plus -255, which equals -324, because the beginning and the end is what we're concerned for. The middle, we don't have to pay attention if I'm explaining it as eloquently as the textbook is. So these are the ends, like the ending of these equations. So take that, minus equals -324. And then, yeah, those two cancel out. And 2 gas, which is the middle, which is part of the Hess's law definition. And yep, that's all.